minus 2 minutes and 50 seconds. Now our final countdown and startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did its static fire. Looking back for Flight 1, we lit those Raptor engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress on the ground systems, improve the efficiency of the rocket. But right now, we're just about to pass 18 minutes away from launch. Winds, again, they're still looking a little bit marginal, so we'll keep an eye on those. We're not working any other technical issues, and the range is expected to be green. If we can't make our test today, we have backup launch opportunities in the coming days. Could be 24 to 48 hours. All just depends on how far we get into the count. So check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate and Shiva out at Hawthorne.
Thanks, Dan. The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised of two elements, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Starship is capable of about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will actually be 3 times more powerful.
Now, with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking about an order of magnitude greater in terms of payload capability to orbit. And that matters because the amount of mass we're able to launch per rocket is critical to creating a self-sustaining city on Mars.
In terms of size, the Super Heavy booster alone stands about 71 meters or 233 feet tall and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet tall with its base. Stacked together, Starship is 396 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about 2.5 times that of Falcon 9, and we've got those 33 much larger Raptor engines, this great view of the launch mount looking up at those engines, and we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to space. Moving up the rocket, Starship is designed for vertical takeoff and landing on any hard surface, and that's as opposed to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. The ship, which we're looking at now, features 6 Raptor engines. 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The body of Starship is also wrapped in a heat shield made up of 18,000 hexagonal ceramic tiles. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection system tiles perform during reentry. And in between the first and second stages is our hot stage, which is critical for our newest separation technique, which we saw in action during Flight Test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been done before as part of a reusable space transportation system, let alone on a vehicle with the size and power of Starship. Now, at about liftoff plus 2.5 minutes, the booster shut down most of its 33 engines, leaving just 3 of them running, and then the ship simultaneously ignited all 6 of its engines. Some clamps separated, and the ship thrusted away. That was the first in-flight test of the heat shield, and we were able to gather a ton of valuable data about hot staging.
We maximize the vehicle's performance by leaving 3 first-stage engines on, so gravity can't rob us of precious velocity, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light the ship's engines. It also reduces risk at stage separation because it creates a passive staging system so that physics will be doing the work instead of mechanical parts pushing the 2 stages away from each other. Ultimately, hot staging could increase Starship's payload to orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
Now, the first stop will be the Moon, and the SpaceX team has been hard at work proving out all of the systems necessary to make that possible. Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo of some of the mock-up suits that are used to demonstrate the range of mobility that astronauts will be expected to have. And we were using these to do human factors demonstrations and figure out the layout of the elevator. So all awesome development work for a future Moon mission.
Super cool. Now, SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the moon.
You couldn't have said it better, Kate. And the moon is just the proving ground. It's just the start. When the time supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
And today's flight test is one more step toward that ultimate goal. We're currently at T-minus 11 minutes, 47 seconds. Let's check in with Dan once again for a countdown update.
Hey, Kate. Still good news from down here at Starbase. We're not tracking any technical issues that are going to block us to a launch. Our T0 time still holding to 8:25 a.m. Central, so just about 11 and a half minutes from now. The real thing we're going to keep an eye on is the winds once we get there. We do have that potential hold at T-minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limits, everything like that. So don't be surprised if we do a hold at T-minus 40. We've done those on previous flights, but we are not tracking any technical issues. The range is going to be green for launch, so all that really great news. We're still loading propellant on the vehicle, on the ship. We're just about done loading the header tanks, the two smaller tanks in the top, and then we'll go back to the main tanks. They're about 85% full, and then booster, both fuel and LOX over 80%, so looking good there. The launch pad itself is getting ready for liftoff. We commanded the booster hold downs open already about 20 minutes ago or so. And then that just means that once that rocket has sufficient thrust to overcome its weight, your thrust to weight ratio goes over 1, it's going to lift off. We don't have a command to actually release the hold downs once it starts up. Just also a reminder, actual liftoff happens a few seconds after you see those engines ignite. So you'll see fire, and then a few seconds before Starship really starts to take to the skies. Our range team just going to keep on making sure land, sea, air are all clear as we really count down. But that's the latest. We're just coming up on 10 minutes before launch. Everything looking good for Starship's third test flight. I'll toss it back to you guys in Hawthorne.
Great, thanks, Dan. Now, if you've been following SpaceX over the years, you've no doubt heard us talk about our goal of full and rapid reusability. Nearly all of the Falcon boosters flown last year and this year have been reused, or as we like to say, flight proven.
We've landed Falcon 9 and Falcon Heavy boosters 283 times since first doing so in 2015. And with Starship, our mission is to take reusability even further by reflying both stages with little downtime between flights. And we plan to fly as often as possible. As we mentioned earlier, rapid and complete reusability is critical to enabling routine spaceflight. The team at Starbase has been hard at work developing and manufacturing the hardware that will ultimately take humans back and forth to the Moon and Mars.
Now, even though we are not recovering Starship today, test flights like these provide the critical data that we need through every phase of flight. And that data informs future missions and gets us to that future where Starships are being recovered and rapidly reflown.
Our teams are also working on the ground systems that will support rapid reusability. When we start recovering Starship boosters, we'll want them to return to the launch site for a quicker turnaround, as you can see here depicted in this animation on your screen. This is when the tower reveals its dual purpose. After launch, the arms or the chopsticks on the tower will help guide the booster into position to ensure a soft landing. Now, if you're thinking that this sounds hard or even impossible to do, well, that's the inspiration for naming them chopsticks. Some of you might recall a little film called The Karate Kid, where Mr. Miyagi famously taught the main character, Daniel, that if he could catch a fly with chopsticks, he could accomplish anything.
Now, today we do have 4 ships and 4 Super Heavy boosters built, with more coming off the production line as our Star Factory continues to grow. These vehicles are slated for future flight tests just like today's, and in fact, just this week we static fired our next ship that's planning to fly and expect to test the booster as soon as the launch mount is free from today's flight test.
Now, as a reminder, today is still just a test. While we really hope to get our splashdown location in the Indian Ocean, but any data received will help us improve. It's the third of many future flight tests for Starship before it becomes fully operational.
And that's the goal of flight tests. They teach us about the limits of our design and improve our understanding of the vehicle, and ultimately help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can promise excitement. And things look like they are moving fast at Starbase, and that's exactly how we like it.
Yeah,
Rapid
exactly.
Iteration is a key of SpaceX.
Yeah, we've done it with all of our major innovative advancements, including Falcon, Dragon, and Starlink. We believe that if you're not failing, you're not learning and improving the design.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, all of the iterative design allows us to make the design better and better to do some of the great accomplishments with reflight that we've had so far.
Exactly. One of the examples that we love to talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally, it was not designed to be reusable. We wanted to prove the initial design, and then when we brought Dragon 2 online, we had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable and also rapidly, at a much rapid pace than they used to be.
Yeah. So, I mean, great learnings from our original Dragon to our new crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes to rocket and spacecraft reusability. Now, we're just under T-minus 6 minutes, so I think it's another good time to check in with Dan for the rest of terminal count. How are we looking, Dan?
Thanks, Shiva. We're looking good. 5 minutes, 35 seconds, and we're counting down. We are just about at closing the prop load sequences on booster and ship. Just a reminder, ship, we're going to close out at around 3 minutes and 30 seconds, booster at about 2 minutes and 50 seconds. Once all of that prop is loaded on board, we'll have about 10 million pounds of propellant on both stages of Starship. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushbacks, clearing out the lines between our prop farm and the vehicles themselves before we get to launch. And then in the next few minutes, we'll get the final guidance system alignments, some final thrust vector control on the booster checks, and all that will be performed. And again, if we need to hold, we have a hold gate built in at T-minus 40 seconds where we can hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to. If we hit that right now, it looks like the most likely reason would be winds. We're not tracking any technical issues to our T0 at 8:25, just about 4.5 minutes from now. So, I mean, everything's really looking good. The booster's almost at full frosty, so we'll see that close out in just a couple of minutes. But we're getting really close to flight, guys.
The excitement is definitely growing here in Hawthorne, SpaceX headquarters. There is a large crowd gathering. You might hear them cheering occasionally. Now, Dan mentioned a good point about the holds. We have an opportunity to today hold for a few minutes. And this is a really cool thing about Starship, and we don't have this opportunity with Falcon or Falcon Heavy. Up until the T-minus 40-second point, aborts are just holds. So anything that would trigger an abort prior to T-minus 40 seconds becomes a hold. So that's a really cool feature to allow the team to wait for final checkouts or assess prop levels, engines, avionics, vehicle pressurization. It's really helpful to ensure a liftoff.
Yeah, and that's something that is very different from Falcon. I'm sure people have watched our launches, and then we get right down past prop load and then have to scrub because of weather or scrub because of an issue on the vehicle. And we don't have the same constraints on our propellant and our system with Starship, which gives us more availability in the window. And sometimes that's all you need. Sometimes the winds dip just enough where you can launch the rocket safely. And otherwise, if you didn't have that ability to hold a few minutes, you might miss that window and then have to recycle to another day.
Yeah, exactly, which is kind of like today. Like we mentioned earlier, winds are the thing that we are watching, so good news there. So we are still continuing to progress. We're looking at liftoff in just under almost 2.5 minutes from now. Super exciting. Like we said before, there's nothing more exciting than watching a test flight for a developmental program, and that's where we're at today.
And like we talked about, we have some really ambitious goals for today's test. But really, the point of today's test is to try to get as much data as we can so we can inform the next iteration of the design of Starship, work those things into flight test number 4 and new objectives there that'll eventually get us to that glorious, rapid, reusable future that we so badly want.
Yeah, for Flight 1, we wanted to clear the pad, and we did. For Flight 2, we wanted to get through hot staging separation, and we did. So today, we want to get even further than that and collect as much data as we possibly can. So with all that being said, we're going to check back in with Dan to take us through the final 2 minutes of terminal count.
All right, we are under 2 minutes away. We have closed out the prop load on the booster and on the ship. And we're starting to hear some good news that it looks like winds are not going to hold us up, so there's a good chance we blow right through that 40-second hold. So we're about 1 minute and 20 seconds away. Just walking you through one last time, we're going to see the engines ignite about 4 seconds before we hit our T0. They're going to ignite in 3 different banks. You'll get 13 of the inners, 15 of the outers, and then the last 5 ignite just 2 minutes before T0. And then after that, the quick disconnect will retract. The engines will start to throttle up, and then we'll see liftoff about 1.5 seconds after T0. So we're under 1 minute away. Don't be shocked if we hold at 40 seconds before, but it sounds like the winds are cooperating today. And we'll be able to move right past that, not tracking any other technical issues that could hold us.
Proceeding past our QD vent gate.
Through the QD vent gate past the 40-second hold.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. 20. So 20 seconds to go. Let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nominal.
30 seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Booster and ship, avionics, power, and telemetry nominal. Acquisition of signal, Corpus Christi.
Continuing to get good call outs. Our trajectory looking nominal, systems looking nominal. Just amazing to see all 33 lit up once again. At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound, getting those onboard views from the ship cameras. Now the next major milestone is going to be a hot staging maneuver. Again, we're going to be doing that in just about 90 seconds. To do that, we're going to shut down all but the 3 center Raptor engines on Super Heavy. That'll be our MECO, our most engines cut off. And then the clamps holding the 2 stages together are going to release. Starship second stage will ignite its engines, the RVACs first, the sea levels right after that. The sea level engines will be splayed or just kind of pointed out at about a 15-degree angle. So if you look close and we get good tracking, you might be able to see those center right after. And so those 6 engines will push Starship off of the booster. All right, counting down now. We're going to be coming up right at around the 3-minute mark on that hot staging maneuver. Again, we'll see the booster engines start to shut down. You'll see all but 3 lights go out in the middle. And then we'll see the engines ignite on ship, pushing it away. And that will start carrying the ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
Stage separation. Boost back startup.
Hot staging confirmed. Boosters now making its way back, seeing 6 engines ignited on ship. Kate, we got a Starship on its way to space and a booster on the way back to the Gulf.
Oh man, I need a moment to pick my jaw up from the floor because these views are just stunning. These are live views from Starship. First stage is currently performing the
ship avionics, power and telemetry nominal.
Good there, news informing us that the second stage or the ship, everything looking good, nominal there. First stage is currently performing the boost back burn, expecting that to last about 1 minute. That boost back burn, propels the booster back towards the coast, taking it to a landing in the waters of the Gulf of Mexico. We're only using the Super Heavy boosters, 13 center engines from here on out. As whenever they relight, you'll be able to see that in the left bottom corner. Those are the ones that can gimbal. In other words, they move and change direction in order to change the thrust to steer the first stage back to Earth. Wow, these are just incredible views coming to us. Everything is looking good for both the first stage on the left-hand side of your screen or the Super Heavy booster, as well as on the right-hand side of your screen, that is Starship, or we also refer to that as the ship. Now, the boost back burn was the first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder of the Stage 1 test objectives, we're looking for controlled ascent, which we have so far. Stage separation, which, gorgeous, we cruised right through it, as well as
on a nominal trajectory.
Good news there, telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path. The ship objectives, we're looking for hot staging, again, cruised right through that. We're looking to demonstrate controlled ascent, as well as orbital insertion. Now, the bottom right-hand corner of the screen shows the ship engine graphics, so be sure to keep an eye on those.
Yep, Kate, this is just a phenomenal test so far. Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, those larger circles, the Raptor vacuum engines, the inner circles, the Raptor sea level engines. We're about 30 seconds away, just under 30 seconds away from the start of the boost back burn. The landing burn on the booster. You can see the grid fins rotating. Those hypersonic grid fins are guiding us through the atmosphere back towards our splashdown site. Again, we're going for a splashdown, a soft splashdown. So for landing burn, we're going to expect to see the 13 center engines light, rapidly bring down the booster's velocity, and then just the 3 in the center for splashdown. Let's see if that'll work. We're getting a few engines. And acquisition of signal. Let's see if we can get some other video of that. Now, this is a test objective today. It is still something that we're attempting to learn. And to make it that far, to demonstrate the controlled re-entry up to that point is pretty darn good. Ship continuing to look nominal with its ascent burn. This burn lasting about 6 minutes total. And we're expecting that this burn will end just after T+8 minutes, about a minute from now. So far, though, I mean, congrats to the team. Making it this far is farther than we've gone. Absolute flight,
da ISS, que é em torno de 27.000 km/h. Enquanto isso, a parte traseira, o Super Boost, né? Voltando para sua base. Vamos ver se vai ser a comemoração da outra vez, né? Que ele chegou e pousou na sua base. Estamos atentos, só observando.
Just stopped a little short of the engine relay, but hey, that's something we can learn for the next one.
Yeah. Now that view that we just had moments ago was a live shot of Star Command. There you see it again. This is our mission control center at Starbase, where vehicle operators are standing by. Now the next milestone coming up is in less than a minute. At that point, ship will, or I'm sorry, actually it already has.
Starship engine cut off.
There we go. As you heard there, by the call out and from the crowd behind us,
Starship orbit insertion.
Starship's 6 Raptor engines have successfully shut down. We heard a call out for nominal orbital insertion, which is incredible. Look at these views, Dan.
I'm just completely blown away right now. What a day. Congratulations to the entire SpaceX team. I mean, this flight pretty much just started, but we're farther than we've ever been before. We've got a Starship not just in space, but on its coast phase into space. Just to recap where we've come, and it's only been 9.5 minutes. How has it only been 9.5 minutes? We lifted off right on time at 8:25 a.m. We didn't have to hold at our gate at all. We had 33 out of 33 Raptor engines open up and light and get us through a nominal ascent. Another successful hot stage. All 6 engines on the ship propelling us into orbit. We did see what looked like a nominal boost back burn. And then we did make it all the way to the landing burn this time. Didn't light all the engines that we expected, and we did lose the booster. We'll have to go through the data to figure out exactly what happened, obviously. So be on the lookout for information about that. But wow, a ship in space. We've got a bunch of, as we said, ambitious objectives ahead of us. Over the next couple of minutes and pretty much over the next hour, where we're going to really, we've got the ship in space. We're now going to take advantage of this and try and learn as much as possible about some of the other systems, including that first ever Raptor relight in space. So it's just going to be incredible. So all of that still to come. The mission just started, but wow, what a liftoff! What a hot stage! What an amazing sight to see Starship there in outer space.
I can't believe we're seeing it in space. This is awesome.
Wonderful.
Now, we are going to be coasting for the next about 30 minutes or so, we'll be back around the T plus 40-minute mark, and that'll be Starship continuing to coast, hit those ambitious test objectives, and then continue on to re-entry. We're not totally sure what video that we'll get, since that normally comes to us as we overfly ground stations, and we don't have a ton of those along our trajectory, but as we have video, we'll be sure to bring that to you.
Starlink may be able to bring us additional communication paths today that will allow us to talk to Starship through re-entry with no communications blackout period. It's a possibility, but either way, we will be live for all of today's milestones. And of course, when we do have views,
signal, Puerto Rico.
especially like the ones that we have now, which I just cannot get over. When we have views, we will be sure to bring those to you live. But no views or no views, we'll see you back here at T plus 40 minutes.
Pez door is opening.
And there we just heard call.
Let me respawn in Rome, please. Yes.
Great news there that test objective is already underway. So come back here, stick around till T plus 40 minutes for coverage of Starship's deorbit burn demonstration, followed by its re-entry and what is sure to be an exciting splashdown.